Hello ladies, today we're going to be looking at lesson 4-1, Polynomial Terminology. So this is our next unit. I know we're starting before Christmas break, but it's time to begin a new unit. So today's learning target is I can apply my knowledge of polynomial terminology by identifying components of an expression. So the first thing we're going to be doing is we have all these expressions in the top of our note sheet. So here's your task. Using the card sort feature on Desmos, organize the expressions above in any way that you see fit. Afterwards, we're going to do a whole class discussion on how we organized our expressions. So make sure you do that Desmos activity. The cards are already typed. You just have to organize them in the way that you think makes sense. Okay, now here's how the mathematicians would organize them. So the mathematicians would organize them by how many terms there are. So I'm actually going to write out how the mathematicians would organize them. So here's how the mathematicians would organize them. They would organize them by putting negative 10x to the fifth with my 4. They would organize them by putting the 2x plus 1 and the 5x minus 3 together. They would then put the 4a squared plus 7a minus 10 with the 10x cubed minus 2x plus 1 and negative 5n to the fourth plus 10n minus 10. And then last but not least, they would put the 8x cubed plus 2x squared plus 3x minus 7 with the 2x cubed minus 5x squared minus 2x plus 12. Now, here's why the mathematicians would organize them that way. And here's why. And here are some definitions that you need to make sure you know by heart because it's very important because we're going to be using these terms repeatedly throughout this unit. So all the expressions in box 1 we call monomials. So I'm giving you the heads up right now. All of these expressions are polynomials. But the thing is, we can have special names for each of our polynomials. So a one-termed polynomial is a monomial. And the reason why we call it a monomial is because they are polynomials with one term. So if you read this out loud, I only have one term. I only have one term. So I can say negative 10x to the fifth. That's one term. I can say 4. That's one term. So every time I have just something by itself like this, that's one term. So these are monomials. Now, when we go into box 2, we call these binomials because they are polynomials with two terms. Think of a bicycle with two wheels. That's what we mean by a two-termed polynomial. So for instance, I have 2x plus 1. 2x is a term, 1 is a term. Boom, that's a binomial. 5x is a term, minus 3 is a term. Boom, that's also a binomial. So binomials are expressions with two terms. When I go into box 3, we call those trinomials because they are polynomials with 3 terms. So when we see the word tri, think of a tricycle, a 3-wheeled bicycle. And we say that because they're polynomials with 3 terms. So for instance, if I look a little closer, 4a squared is a term, 7a is a term, and minus 10 is a term. 3 terms, trinomial. 10x cubed is a term, minus 2x is a term, and 1 is a term, also a trinomial. Negative 5n to the fourth, 10n minus 10, also a trinomial. So all of these expressions are 3 terms, and they are all polynomials, but we can be specific in naming them a trinomial. And then last but not least, the expressions in box 4, you don't need to know this. They are called quadrinomials because they are polynomials with just 4 terms. But if you want, you can just call them a polynomial because you don't need to tell me that they're a quadrinomial. You'll never need to know that. If you ever see a 4-termed expression, you can just write polynomial. There's no need to be specific. Typically, a word bank will be provided for you on like a quiz or a test or a homework assignment. So just make sure that you use the correct words. I'll mainly be staying with box 1, box 2, and box 3. So those 3-termed, 2-termed, and 1-termed expressions. Now note, all the expressions above are classified as polynomials, but remember we can be very specific when classifying them by calling them monomials, binomials, or trinomials. Let's go on to some practice. So polynomial expressions. The definition of a polynomial is any expression in the form of, time to get mathy on ya, ax to the n plus bx to the n minus 1 plus cx to the n minus 2 plus ... plus a constant, where the exponents are n, n minus 1, n minus 2, etc. They are all positive integers. Note, not all powers need to be present because the coefficients a, b, and c can be 0. So basically what this means is if you have an expression with an exponent that's a number, x squared plus 5x plus 1, that's a polynomial. You can also just have x squared plus 1, that's a polynomial. Anytime you have an expression with multiple terms, it's a polynomial. There's just a little catch. All your exponents have to be whole numbers, and they have to be positive. Also, your exponent cannot be in the denominator of the fraction if there is one. So for instance, if I have 1 over x plus x squared plus 3x, that's not going to work because I have a 1 over x. That's not allowed. So I can't have a variable in my denominator. So let's look at these examples. Of the expressions below, circle all of the ones that represent polynomials. Discuss why they aren't polynomials that fail the definitions above. So if I look at my first example, I have 4x squared plus 8x plus 1. If I look, my exponent is a number, and it's a whole number. I have an 8x to the first, that's fine, and I have more than one term. So this is a polynomial. And if you want, you can be specific and call this a trinomial. Let's go on to example 2. I have 9x squared plus 2x plus 1 over x. If you look, 9x squared is fine, 2x is fine, but again, I don't like when my x is in the denominator. So this is not a polynomial. If you didn't have the 1 over x, then yes, it would be a polynomial. Number 3, I have 2 to the x plus 3 to the x plus 4 to the x. This is not a polynomial because if you look, your exponents are all variables. If they were numbers, that would be fine. And then last but not least, we have 2x squared plus 5x cubed minus x plus 8. I just double check. Nice, nice, nice. Good. It's a polynomial. Standard form. In a polynomial with one variable with the same letter, so for instance, all x's, all y's, all q's, whatever your heart desires, write the term with the highest exponent first, then order the terms with the descending exponents. So think of the movies. If you're thinking of like a recent movie, I'm not sure what movies are out because we're in a pandemic, but let's see, what movie is good? Oh, one of my favorite movies is The Great Gatsby. So the person in The Great Gatsby is Leonardo DiCaprio. So Leonardo DiCaprio would be at the top of the poster, the top of the credits, all that stuff. So when you look at expressions in math, the thing that we want in front of our expression is the exponent that is largest. We want the thing that's going to be taking control of our expression or just be in charge. So if I look at this example right here, where I have 5x minus 6x cubed plus 5x squared plus 1, the term that's dominating my expression is the 6x cubed. And if I look, it's a negative 6x cubed. The reason why I'm saying the 6x cubed is dominating is because the 3 is the highest exponent. So when I rewrite this in standard form, I'm going to put my negative 6x cubed first. So I have negative 6x cubed. And what I do when I rewrite them is I cross it out as I use it. Now I go to my next exponent that's lowest. My next lowest exponent is my 5x squared, and that's positive, so I'm going to keep it positive. I use it, so I cross it out. My next term that I can use is a 5x. And now that I use my 5x, I cross it out. And now my last term that's left is my plus 1. So that's how I'd write a polynomial in standard form. There's going to be a few exercises on your delta math that you will do where you just rearrange your expression by putting it in standard form. Now, last but not least, like terms. The reason why we need to go over like terms is because tomorrow's lesson on adding and subtracting polynomial expressions is all based on the fact of are they like terms? So by definition, like terms are terms whose variables such as x or y with any exponent such as the 2 and x squared are the same. What we're going to do is we're going to determine if the following pairs are like terms. If I look, I have a 5x and a minus 7x. The things we need to ask ourselves, do they have the same variable? Do they have the same exponent? If I look, I have a 5x and a minus 7x. These are like terms because I just have an x and I just have an x. And if I look at my next example, I have a 4p and a 9p. Note, I didn't say 4p squared and 9p cubed. I just said 4p and 9p. These are also like terms. And then last but not least, I have a 6x and a minus 4y. These are not like terms because they both aren't an x and they both aren't a y, or they both aren't a y. And that's it for today's lesson. If you have any questions, please email myself, Miss Townsend, or Miss Jimenez. Have a great day, ladies.